alive! It's alive! What up, YouTube? Welcome back to another Robot Wars video. Today we're actually building the feckin' thing. We're going to be like wiring it all up, sticking it down with Velcro to the baseboard, and then trying to sync the transmitter, and we should be good. So let's get into it. As you can see, I've made a start. I've started putting the Velcro bits down. These are for the different components, just as a sort of a quick way of mounting them. So just a piece of Velcro. This is the dog barking. I'll cut that out, it's fine. This is the Velcro heavy duty stuff, which is good stuff from Amazon. And then strong stuff as well. If you get this in the wrong place, oh, that'll do. It's exceptionally tough. So we just cut a hole into that there to bring the wires through, and so I'm just going to quickly show you how I cut these pieces or whatever, just in case you were unsure or never used this stuff before. So I'm just going to where's my pair of scissors? Cut a piece, just a strip of the tough as fuck Velcro. I shouldn't swear, should I? Tough as all nails Velcro. Just cut the two pieces. I'm just going to keep this wrapped. Stop it. So where's my other piece? There we are. So this bottom piece, just going to stick straight to the bottom of the ESC. And a good tip if you're doing this method yourself, good tip is to, rather than to try and stick that down and then try and eyeball it where it is, stick this to upside down to that first, and then stick this onto your board. Get lost, get off. So in this case that's about in the right place, or roughly. So there we go. And then when you peel this off, seriously good strong stuff. And there you have it. Okay, the next step is just to solder all the connectors onto these different connections for the motors and different stuff. The receiver doesn't need a direct connection because it actually powers off of the little PWM things off of the controllers. So all we're going to do is solder these XT60 connectors on the end of these, and then we'll be back. So as this bit's playing of me just soldering the connectors on and struggling like hell, I thought it'd be a good opportunity to sort of let you know on a tip that I'd come across. If you're like me and don't have a lot of money and bought a, like in my case, the Antex, I think it is, 80 watt soldering iron, it's got the oomph to be able to solder these cables because it's nice and powerful, but it gets too hot, way too hot, which means the tip of the soldering iron actually oxidizes really fast, which is not good for a good solder joint. It makes it very hard for the solder to actually stick to the soldering iron, and it makes it very hard for you to get any heat into the actual wire you're trying to solder. So, as a quick tip I found, is if you've got a fan, any type of fan size, I was actually using a USB desk fan and then moved up to just a regular fan, just have that blowing on low setting, just a nice stream of cool air over your soldering iron when it's on your bench, and then that just stops the soldering iron from getting to the temperature where it'll oxidize in seconds, and it'll give you a lot longer time to be able to actually put the solder onto the soldering iron and get a really good connection. My solder joints went from being pretty pitiful to really quite good for someone that's never soldered before in a very short amount of time. So there's one for you, and I'll let you carry on watching me struggle with some heat shrink, and then I'll see you in the next bit. Just as a side note, I actually changed from using XD60 connectors to XD90s. A, because they can handle more current, and B, they're a lot easier to solder. Now, you've probably noticed there's a bit of time since the last segment's been recorded. That's mainly because A, I've been on holiday, B, I've had, like, problems with my eyes and stuff that needs sorting. It's fine, don't worry. And I've had a cold, as you could probably hear the sort of tail end of that. So, as it is, this has been a bit longer than I wanted it to be, but we're cracking on now. We're doing it. We're doing it. Now, if you've been following the guide that I've been following, you'll notice that I'm actually not bothering with a switch, because in the guide he uses a fingertech switch, which is good. Don't get me wrong, like, it's just I looked up the rules and things like that, and they just recommended a link, removable link, as well as a switch, or either or kind of thing, as long as you've got one safety feature involved. So I just went with the removable link, being as I already had the connector available. So, and the removable link is literally just, this would be connected to your robot. This is what your main power would run. And then you just, when this is, oh, it's quite stiff. When this is out, there's no power can possibly get to the robot, because obviously the circuit's broke. But as soon as you link that together like that, it just loops round and completes the circuit and gives you power to your robot. So that's complete. So we're going to be moving on. I'm going to try and this with the other connector. These are the two battery connectors, because they're bullet connectors. These are going to be going to the battery, which is conveniently placed in this ammo box, because I'm paranoid about it exploding. Just simple bullet connectors. And one thing to note, if you're going to do this and you have this particular battery, these are alternating. They're not the same connector. They alternate for positive and negative. So it's one thing to check before you start. So I'm going to get cracking again then. Just as a bit of a tip I found on the internet, basically these wires are really thick. They're really difficult to solder. Like, because at the moment I'm having to join, I'm joining some 12 gauge wire to some 10 gauge, because it's going to split from, just where that connection is there, it's going to, oh, you can't even see it, split from there into then two motors. So, I'm basically going to go from 14, I keep saying 14 gauge, 10 gauge to split off to two 12 gauge. Now, 12 gauge obviously being smaller, the 10 gauge is the thicker wire. A good tip I found on the internet was to split the two pieces of wire, so it's still the full cable, but just split them in half and solder one. to this cable here, so this one cable solder the other to the other cable, and then heat shrink them all together like that. So when it's finished, you'll have a second cable. Just grab the other end of this as an example. You'll have a second cable coming off that. You'll put them together, and then you'll heat shrink. Put a big piece of heat shrink over that, and then those will be two solid connections, all one together. Also, I'm gonna, for paranoia's sake, I'm gonna put a bit of solder in between the two connections as well, just to make sure it's good, because this is the main, obviously the main power lead for the robot. I don't want it fucking blowing up or anything, you know. So I'm gonna carry on with this, and I'll show you what I've done afterwards. Okay, granted it's not the most prettiest thing in the world, but that's the general idea. All the wires are covered with solder. It's really strong, and I've put a little bit in between where I could, just to make that joint there a little bit stronger. So now it's just a case of putting some heat shrink on. So I've got some nice big heat shrink here, and that would just go over there. And I'm going to put mine slightly more over here, so most of the support is on these two wires here. And there we go. So I'll just do that quickly to show you. Just seeing, this is about the limit of what this one will shrink to. So I might have to use a bit of ingenuity, because I have some spare of the slightly smaller size. So I might be able to just nip that over the ends. I'd like it to be, I'd like it to be not on the floor. That's what I'd like it to be. I'd like it to be just a little bit tighter on the edges if I can. So I'm just gonna, that'll work well if I just overlap some of the existing stuff over the edge there, and same over there. I think it'll be a good connection. Right, but you get the general gist anyway. I'll put another piece over this end just to close that up a bit better, although it probably isn't needed, but I'm going to be paranoid. Paranoid's better in this game. And then we'll crack on with the next bit. So there we go, there's the main loom now wired up. Those you go to your battery, then these goes to each of the speed controllers, which are here. So these just connect up as you'd expect, like so. Yeah. The next job is now soldering the motors, which will be interesting because I don't know which way it goes round. So if it ends up going backwards when I plug it all in together, we know why. Better get on with it. Right then, I've got everything wired up. I think everything's right. I hope everything's right at this point. I've just plugged the one in only, just in case there is something up, then nothing will blow up. Or I'll only blow one speed controller up rather than both, which is unfortunate at best. So let's hope nothing goes bang. I'm really scared. Nothing's melted. Good. That's good. That's a good start. Right. Right, let's get the controller. I need to find somewhere binding this. I don't actually know how to bind it. So I'm just going to stop and then I'll be back when I figure out how to bind this thing. Okay, I've done the bind sequence. It's powered on. And it seems to be working. Although I've got something wrong somewhere because up and down does the same wheel. So So I need to do a bit of adjustment, find out, like, plug the other one in and see how it goes. So I'm going to do that now.
3 hours later.
Okay, left and right does nout. Okay, I am so confused. You have no idea how confused I am right now about which direction they're supposed to be going. Well, it's the next day. I finally got it working. There was a bunch of sort of mixing things that I didn't have a clue about, so I just spent the last sort of evening Googling, looking up, and I found out I'm just an idiot. On this model here, I'd realised that I had it set to helicopter, which means all these controls completely change. So, because as it is, it's a straight sort of, I'm going to adjust that. As a procedure you can do, I'll probably make a little video about that, where you can take the back off, put the spring back on. Well, it's not even, you just tighten a screw and it puts the screw thing back on. But you don't care about that, you care about this, don't you? And the fact that it's working. Quite well indeed. So I've mixed it so it's all on. Alright, originally in the video I think I said I put it on, what was it? It was on throttle and rudder, I think. And I found out since changing that, it's a bad idea, because this model doesn't support, you can parent a mix from throttle to something else, but you can't parent, you can't have the throttle as a child. So in other words, you can have the throttle control something else, but you can't have something else control the throttle. So I switched over to this, did a bit of research, found out that the controls are a bit squiffy, because they are a different scheme when you're using a helicopter than you're using a plane. So I switched to a plane, did a bit of mix and reversed, I think it was aileron. Should we have a quick look? Let's set up, and then there's reverse. Yeah, so I reversed elevator. Everything else is normal. I've reversed elevator, and then in case you wanting to do this yourself and you've got the same model, start again, because I don't know what I'm doing. Mix 2, so mix 1 is set to aileron controls elevator at plus 100% on both, and mix 2 is set to elevator controls aileron and minus 100% on both. So basically this one reverses the wheels when you turn left and right, and the other one obviously makes them both go forward. And that's about it. And then my phone's ringing. God damn it. Alright, just as a bit of a rundown, just in case it wasn't sort of obvious at all what I was doing, I shall post a picture of the wiring diagram I used from RoboWars Australia. Very good people, or very good man, I think it's just him on his own, but basically you have your main power. Your main power comes from your battery, and then your main power goes through, like the live goes through into a connector, which then just goes back straight through. Now the reason you do this is obviously for your safety link. This acts as a switch, but it's a lot more reliable than a switch. It can't get fused together, and if it does, it's a good chance, with that, yanking on that is a good chance you'll pull it out if there's an emergency or anything like that. And then so you've got your live, then comes out, it splits into this, and I've just soldered it, soldered it, and I'm going to turn that off in a minute. Heat shrink, and that splits off into 2 separate connectors. And same with the neutral, except the neutral doesn't have the link, it just goes straight through, splits, goes into 2 connectors. Then these 2 connectors connect to the positive and negative of each of the speed controllers. These are for each of the wheels. And then the lead, the PWM lead, comes from the speed controllers, each one. And then this is what's going into the two different, in this case, elevator and aileron. That's what receives your signal. It also powers the receiver, and then the receiver receives the signal and tells what these speed controllers how much power to give out to the motors. And then the motors just come out here. I've kind of tried to stick to colour coding them. It doesn't matter which way you go around it, put them, which way you put them around. It will just mean it'll either go backwards or forwards. So, but I've just kept them the same, and luckily I got them right first time. But if you're doing this yourself, you might want to give it have a bit of a fiddle with it. If you got them the right way around, I'd recommend do what I did. Leave the last piece of heat shrink, just put it over so it just stops any shorts, and then leave it. I'm going to heat shrink that on properly now. Now I know that's the right way around and everything. And then just resolder them if you need to. Just solder the two cables, just change them around, and then you should be good. That's basically Karatakos in a nutshell. Well, not in a nutshell, he's kind of naked at the moment, but our next video hopefully will be finding some sort of what's a good material to sort of build as a chassis, build it together or whatever, and then start sort of brainstorming how I'm going to get an axe on this. For the time being, it may be just a push bot for now until I can research some more, but we'll see how things goes. Now, apologies for the noise, my mother's sorting out Lego, but you want to see it running, don't you? So I would have took it outside, but it's currently raining, so I'll do a proper video later on, but it's pretty quick considering. That's only me using about half power. I'll try full power, but I don't know if I'm going to be able to stop it. Not bad. Running well. I think it's going to be good. I think that's about it for this video. We've got all the sort of main bits working, like it's running, which is freaking good. Next job is to put armour, make the chassis and all that jazz. I'm going to do a bit of research in between this video and the next one. Hopefully the next one, when it's a bit nicer out, I'll have a proper sort of view of the robot working, so you can see what it's kind of capable of. And then the following video hopefully is building the chassis, so that'd be cool. Well, thank you everybody for watching. If you enjoyed, please like, comment and subscribe and all the lovely stuff, please. And stay tuned, so hopefully more of these videos will be coming sooner rather than later. Now I have a bit more time on my hands. I'll see you all next time. Is this awkward yet?
I am the danger.